All right, hi everyone. So real fast, maybe not too fast, but I just wanted to go over some of the topics we're covering right now in physics with our properties of waves, because we're going to go through the next little section pretty quickly. Should be review. We're going to talk about words like reflection, refraction, diffraction, absorption, interference, standing wave, and resonance. And these are all words that we go through in 8th grade and use, and I want to make sure that we're on the same page so that when we come back from Thanksgiving, we can hop into some deeper issues with mechanical and electromagnetic waves. So we're going to be studying sound, we're going to be studying light and electromagnetism, and that leads us into electricity and Coulomb's law and some really fun topics in the world of electromagnetism itself. So here's our first little section. I'm going to go through these and talk about these. Some of this is in your textbook. I'll put a link down to that in the notes on Classroom, but some of it is just out of my brain and stuff that I would stand up here and lecture you with, but wanted to make sure that you had a way to see this otherwise, hence this video. So our first bit is going to be on reflection, refraction, and absorption. So reflection, as you might remember from 8th grade, is a wave that bounces off and heads in a different direction. So it bounces off of something and heads in a different direction. So I'm going to highlight that in yellow. Reflection typically has 3 properties. So reflection is when a wave bounces off of something and heads in a different direction. It doesn't have to be opposite. Sometimes it is, but it doesn't have to be. So in this case, we have this maglite here, this big flashlight, and it's bouncing off of a mirror and reflecting. So you have 3 properties of reflection, and you do need to know these. You have the angle of incidence, which is A. So here's the angle. B is going to be our normal, so our perpendicular line and the angle. And in this case, we have a 90-degree angle, so it's kind of easy. So we have the angle of incidence, the angle between the incoming wave and what we call normal. And then on the other side of the normal, we have C, which is the angle of reflection. So angle of incidence, where the light, in this case, the wave of light is striking the mirror, and the reflection here gives us the other component, which is the angle of reflection, and all that together gives us the total reflection or reflective property of this interaction between wave and matter. But in this case, the tricky part for a lot of students is always B, or the normal. But makes total sense. So angle of incidence and then angle of reflection. In a 90-degree angle, which is really nice to have, you have 45 and 45 degrees, right? But sometimes this is going to be 60 degrees, or you might have a 45-degree angle of reflection itself. So it doesn't always have to be 90 degrees, but it's for our purposes, it's always nice to have that. But we will have some examples where your angle of reflection is going to be different based on the type of wave or the type of property, especially with sound. So angle of incidence, the normal, that line in the middle, and the angle of reflection. So that's our little bit on reflection. And then we have refraction. And refraction is when light waves are transmitted from one medium to another medium. They start bending. So when light travels from one medium to another medium, that explains why if you take something like a water jug, it's hard to see because I've got stickers everywhere, but we have our water, and when the water is still, if I were to place this pen into the water, which I'm going to do, I'll rinse it out, I promise. I don't know if you can see, but because of the refraction here, the pen looks like it's bending. It has nothing to do with the property of this water. It's not special water, it's just typical H2O and a pen that's now wet. But that is due to refraction, because light waves are transmitted from the medium of air that we have here, and then here water transmits light a little differently, so the observation is going to be different, and that's called refraction. So when light waves are transmitted from one medium to another, here's our definition, they also bend in different directions. This bending is due to refraction, or the bending of waves due to a change in speed. So light travels at different speed in different mediums, theoretically. We'll talk about the change in speed. We started on that yesterday a little bit, and I was talking about how we can slow down, how we observe different types of light and energy, but especially sound. sound travels at different speeds depending on mediums. When a wave enters a new medium at an angle other than perpendicular, it changes direction. For instance, when light is directed at water at an angle, as in our figure down here, which we're going to look at, the light slows down and bends downward. The wave bends towards the normal, the imaginary line that runs perpendicular. So again, just like with our last illustration, here's our flashlight, and we're going to shine a beam of light into the water, and it bends, just like our pen bent when I put it into the water here. And that beam of light bending has a different angle of incidence and our refracted angle here. So refraction. When light waves are transmitted from one medium to another, they bend in different directions. The bending is due to change in speed of something like light or sound. Any type of wave, doesn't have to be light. We keep using light as our example. And then we have diffraction. So we had refraction, now we have diffraction. So this has something to do with a really cool effect called the Doppler effect as well, and we'll talk about that in a couple of weeks when we do sound. But diffraction is when light travels or sound and can actually bend. So here's our glossary. The bending or spreading of waves as they move around a barrier or pass through an opening. So the bending or spreading of waves, electromagnetic or mechanical, as they move around a barrier or pass through an opening. Now sometimes we want barriers, sometimes we don't, but diffraction just means as light or sound travels around a barrier. So that's why you can hear me even if you're standing outside of my classroom and you're walking towards the gym and I shout something, you could hear me around that corner, even though it's not a straight shot, right? And then last, we have absorption in this section. In absorption, the energy of a wave is transferred to a material it encounters. So we're going to highlight that. So absorption. When light waves encounter the surface of different materials, they may be reflected, refracted, or absorbed. So we have stuff like in soundproof rooms where they make music albums, that kind of thing, or sound effects. A lot of times the rooms will have those foam paddings. I used to have a podcast studio in my office, and the room was like foam padded so that we didn't have echo. So like in my classroom here, we have a lot of echo. So when it's just me and I'm talking into my computer, it's very awkward. I'm able to hear my echo because my sound waves are literally bouncing off the walls, these concrete walls, and reflecting back to me. So that's what an echo is. But the same thing with light. And you can actually make materials that absorb light. And we'll talk about that with my sunglasses today in class as well. So absorption is another way that light or waves, sound as well, can interact with matter. So light can be, or sound any wave can be reflected, refracted, sometimes diffracted, or absorbed. All right, let's go on. And we get to interference, and this is the part where I wanted to do a little bit more, so I'm going to pause it there, and we're going to come back and we're going to do another video all about interference because it's super interesting, I think, and it deserves its own video.